Hello and welcome to section 1. So in this video, we're going to talk you all through the setup, right? How to set your hypervisor up, as well as the actual virtual machine within your hypervisor. We're going to go over some of the basics of Linux, right? So file navigation, file creation, deletion, right? All of the things that we need to be proficient in our Linux command line systems here. Additionally, we'll talk about basic scripts, right? How to write it in our command line, as well as how to write them in text editors and potentially automate that in the future. And then lastly, we'll talk about how to find files, right? How to use the find command, search within those files, as well as some other small details such as exit statuses, input-output redirection, and piping, right? So stay tuned for all of that, but I'm excited to start up this first section with you all. All right, welcome back. So, as we spoke about before, I'm going to be showing you all how to download VMware Workstation Player for Windows in this video. I'll also be showing you how to download Ubuntu and upload it onto VMware Workstation. As I said before, the way to think about those two devices, right, those two different tools, is VM Workstation Player, or VMware Workstation Player rather, is the DVD player, and Ubuntu, right, is the DVD we're playing, right? So to show you what I mean, when I open up the program that I will be showing you how to download in just a second, we can see that I have a couple of options here, right? VMware Workstation Player, right? This is what holds my library of what we call VMs. As you can see, I have different operating systems. I have an Ubuntu machine, right, that I've dedicated a specific amount of RAM to. I have a Hadoop machine, a Kali machine, an MX Linux machine, right? And basically what we're looking at right now is a library of different operating systems that I have uploaded to VMware. Right? A good way to think about this is it's similar to Audible, right? Audible, right, is your overall library. It's the tool you use to play audio books, right? In that same way, VMware Workstation Player, right, is our equivalent to Audible, right? And these different operating systems are basically the book equivalent, right? As I said before, right, when it comes to virtual machines, right, these are going to be miniature computers that we're running on our hardware, right? This is going to share hardware with my Windows machine, right, that we see in the background here. And I'll show you a little bit later on what I mean by that. But first, let's download VMware Workstation Player. So I'm going to type into Google VMware Workstation Player. And as I said before, this video is for Windows. Right? There is also the video up for Mac. So if that suits your operating system, feel free to click on that as well. I'm going to type in Windows. I'm going to click the first link, right? And when we get there, we're going to see download VMware Workstation Player. It's going to say contact us. We don't want to contact them. So I'm just going to scroll down a little bit, just go straight to download. Right, and we see here two options, one for Windows, one for Linux. As I said before, there is another video up that is specifically for Mac. The process is a little bit different because you're technically using a different version of VMware. We're not going to be using Workstation for Mac. We're actually going to use Fusion, right? And both will work perfectly fine. I just want to show for the setup those different steps. I'm going to hit download, right? And as you see here in the bottom left corner, we're going to see that download start. Now, for most of us, when we hit download, right, our default download location is going to be to our actual downloads folder, right, as you can see right here. I'm going to cancel this one, right, because I've already downloaded that program, right, but you all, of course, would let that go to fruition. So we see right in my downloads folder, I see VMware Player Full 16.2.1. That's the version number of the program we just downloaded. I'm going to double click that. I'm going to hit yes for do I want to allow this app to make changes, right? Those changes are going to be, it's going to download. Now we're just going to wait a couple moments and it should pop up the installer, right? And that installer is what we're going to use to configure our program here. Right. Now we see this setup wizard. I'm going to hit next. I'm going to accept the terms in the license agreement. I'm going to hit next one more time. For this pane, I'm going to leave the defaults, right? I don't want the enhanced keyboard driver, right? It's not necessary for this course. And then also, I want to make sure that VMware Workstation Console Tools is included in my system path. So I'm going to hit next. This one is up to personal preference, right? Join the VMware Customer Experience Improvement Program. I'm going to uncheck that. What that just means is whenever you run into problems with your VMware Workstation Player program, it'll send it to VMware so that they can analyze it and improve the program. You can leave this checked or unchecked. I typically leave it as unchecked just so I don't have any more information leaving than I need. I'm going to leave the top one checked. This is just going to give us updates whenever we start up our machine, which I am a fan of. I'm going to hit next. This is another personal preference one, right? Do you want to create a shortcut on your desktop? Do you want to create a shortcut on your start menu program? I'm going to leave both checked, right? I want both of those things. For those who are unfamiliar with the start menu programs folder, what it really means is if you leave this checked in, I'll be able to go to the search option here. I'll be able to type in VMware, right? And I will see my program pop up, right? And I'll hit next one more time. Last but not least, for you all, it will say install. For me, it says upgrade because I already have the program. You should hit install. It'll take a couple moments, and then you are good to go. So let me quit out of this and show you what will happen, right? What you will get out of this. So once you are done installing, you will be able to type into your search bar here, VMware Workstation, right? Or just VMware, and it'll pop up. You'll also be able to access this on your desktop, assuming you left that check mark, right, for your desktop icon. When you open it up, your program is going to be empty, right, because you will not have any virtual machines. Mine, of course, has a couple because I've been using this program for quite some time now, right? So this is step one, right? This is the first thing we have to download. Step two, the second thing we have to download is going to be the actual VM, the actual virtual machine that we will use this program to run. I'm going to open up another tab in Google. I'm going to look up Ubuntu, download, and hit enter. Right, and we're going to go once again to the first option on Google, download Ubuntu desktop. Right, 20.04.4.3, right, this looks perfect. I'm going to download it, right, and it will pop up in the bottom left corner once the download starts, right, and we see that. This download's going to take a little bit longer, right, I'm going to cancel this one as well because I already have it, right. This download's going to take a little bit longer, probably around, depending on your connection, 5 to 10 minutes. So once Ubuntu has downloaded, what we can now do is we can go to VMware Workstation Player. Right, I'm going to open this up. We can hit create a new virtual machine, installer disk image. Right, we're going to hit browse, and you're going to need to navigate to Ubuntu 20.0.04.3. Right, the ISO image that you have downloaded before. Right, I'm going to double click that. Next up, we're going to hit next. Put your full name in. I'm going to put in Ryan. Username, I'm going to put Ryan as well. Password, I'm going to type my password in. Right, yours will obviously be different depending on what your preferred password is. Right, just make sure those two match. We're going to hit next again. Virtual machine name, you could just name this Ubuntu. Right. The default works as well, right? This is going to be arbitrary, just whatever allows you to recognize this machine and differentiate it from other machines that we'll be adding. I'm going to hit next one more time. So the next thing it asks us is for disk capacity. This is asking what or the amount of storage you will need for your VM. For the purposes of this course, 20 gigabytes will be perfectly fine. We're not going to be downloading major programs. We're not going to be downloading videos, right? So this amount of storage is actually pretty good. And keep in mind that you need this amount of storage on your host machine to be available. Next up, it's going to ask, do I want to store the virtual disk as a single file or split it up into multiple files? Right? The reason we split it up into multiple is it's actually going to make it easier if you ever need to move your VM from your host machine that you're using right now to a future machine, or if you're backing it up, right? So split virtual disk is the best way to go here. Customizing hardware, do not worry too much about this, right? We can always customize our hardware after the fact. Right? The only thing that you cannot customize, right, or is a bit of a pain to actually modify after the fact, is going to be this maximum disk size here. So I'm going to hit finish, right? And I also left it checked to run the VM once it's done. And it's going to go through this setup process. My Ubuntu machine just finished installing. I now see Ryan listed. And as I mentioned before, when I hit this, right, when I make this smaller and then enter full screen, now we can see the entire screen is now covered, right, now that the installation is done. I'm going to hit the account I made before, type in my my password, and I will now be logged into our Ubuntu machine. Just a little quick synopsis. We have Firefox here. We also have our file structure right here. And this file structure is going to be a little bit different from Windows, but really not all that much. It's going to be similar in the sense that we see documents and downloads and music, right? So a lot of similar folder names, right? Other than that, last but not least, the only other thing I'd like to introduce is by hitting the bottom left corner, right, this little icons tab. we can go up to the search bar, hit Linux, or excuse me, terminal, and we can open up our terminal. Just to close out, in order to shut this machine down, you could do it one of two ways. You could either hit the power button up here, hit power off, like that, or you could just quit out of this by Xing out on the box here. Right? You see that little X mark, right? You could hit power off as well, right? So two different options, and both will do the same thing. Right, just keep in mind, as soon as you turn it off, your VMware Workstation Player window will close as well. So thank you all for tuning in. In the next video, we're going to be talking about some more commands, right? And start teaching you how to work with the terminal. Hello and welcome. So in the last video, I showed you all how to download VMware Fusion as well as the Ubuntu VM in Windows. For this video, I want to walk you all how to do it in Mac OS, just in case that is your OS of choice. So step one, look up VMware Fusion. We're actually going to be using a different version of VMware. They have a completely different VMware version set up for Mac specifically. You're going to scroll down, go to Run Windows and More on Mac VMware Fusion. This is going to bring you to a page where it prompts you to buy, but we're allowed to get our own personal license for free. Now, when we click on that, register to get our key now, one thing you're going to have to do, right, is once you click on license and download, you're going to be prompted to log in, create an account, right, in order to get this download running. So once you log in and create an account, down here, that download will populate. So of course, I will not demo that part, right? That should be pretty straightforward there. Feel free to let me know if you all have any challenges in this particular piece. Once VMware is running for you all, what you should be able to do now, right, is type in VMware Fusion, right, and open up the app. Right, what it will look like is you'll have in this top bar, right, this little library app. You'll also be able to basically pop up it from your applications folder like you normally can with most of your other Mac OS applications, right? And the way we boot up our Ubuntu machine, right, is first we have to download it, right? And then we'll add it to this library, similar to the Windows process. So step one here, right, I'm going to go back a couple steps, is looking up Ubuntu download, scrolling down, getting past the ads, right? Clicking download Ubuntu desktop, clicking on download next to Ubuntu 20.04.3 LTS. And then last but not least, our download is going to start in the bottom left corner here. You can see the one that I downloaded previously. This download will take you all probably around 20 to 30 minutes, depending on your network connection, right? But feel free to pause the video, wait those 20 to 30 minutes out, and then come back when you're ready. For those who are ready to move forward, what you can now do is you could open up the library, right, for VMware Fusion up in this top bar here. I have my icon. You can hit create new virtual machine. And I'm just going to drag this from my second monitor over, and you'll be shown this window right here. All you have to do is double click install from disk or image. We have an ISO image that we'll be installing from. So I'm going to double click here. I'm going to hit use another disk or disk image, and I'm going to find my ISO that I have just downloaded right here and double click that. Once that is booted up, right, I see right here, Ubuntu 20.04.3 ISO. I'm going to hit continue. Display name, account name, all looks good. I'm going to add my password as well. Hit continue. And then last but not least, I'm going to hit finish. Right? You can customize these settings. I would say that these default settings are usually pretty spot on. The difference between this machine and the Windows machine, Windows requires us to be a little bit pickier with the settings, whereas this looks pretty good. If you're having performance issues, what I will say is you can increase the amount of memory you're using, depending on how strong your actual hardware is for the machine you all are using. For most Macs, though, I think 4 GB should be sufficient, right, and 2 CPUs. Right, hit finish, save. This is going to save it to your virtual machines folder, which it creates for you. And you'll see right away this machine will boot up. So fairly simple process. Honestly, in a lot of ways, this process is much simpler than it is for Windows. The only thing that's a little bit trickier is downloading VMware Fusion itself, because you have that added step of creating an account before you can do it. But right here, you're going to see some installations, right? And if you get this far, that means you are successful. right? So if you got this far, then you are good to go. Your machine is properly set up. It's going to do a couple more installation steps. It's really just configuring just a couple more settings, but you're ready to go and to continue with the course. So I'll see you all in the next video. Hello and welcome. So today I'm going to be giving us an introduction to the Linux command line, right? And in a nutshell, what we're going to talk about is we're going to go over general command syntax, how to navigate in the command line, how to create and delete files, and then last but not least, how to move and copy those files. First up, let me actually delete this and start from the beginning. What I'm going to do is in the bottom left corner of my Windows machine, I'm going to hit the search bar and I'm going to type in VMware, right? This is how I boot up my application. For you all, it may be on your desktop. You may do it the same way, right? Whichever way you open it usually is the best way to do it here. Next up, I'm going to double click on my Ubuntu box. I currently have it open. I'm going to actually close it out real quick and start it up from scratch, right? But you all should only see one machine, right? Because in the last video, we only booted up one machine. For you, I'm going to have a couple, or right, as you see here, I have a couple. We're going to choose the one machine we have, our Ubuntu box. It's going to load for a little bit. It's going to take a moment. One thing to note here is it's important to remember the password that you first generated the box with, right? When it came to downloading that ISO file from the previous video, uploading it to VMware and running our VM, it's important for us to remember the password that we configured this account with, right? We see this Ryan account, and Ryan is actually the username here, and I will put my password in. Perfect. Next up, I'm going to hit this icon to make this full screen, make this a little bit bigger for us. All right, so now we are in the Ubuntu desktop. Now you might notice a difference between your left bar and my left bar, right? My left bar actually has the terminal here. I'm going to remove this and show you how to get it there, how to get it added to your favorites list. Well, first up, you could click in this bottom left corner. In the search bar, you could type in terminal, and then you can right click and hit add to favorites, right? And this will add it to the quick start bar that you see to the left here. So I'm going to click escape. We see it now in this quick start bar. I'm now going to open up my terminal. I'm going to snap it all the way to the right. I'm going to hit Control Shift plus to make the font a little bit bigger for you all to see. And we have now opened up our terminal, right? And to teach you all the first command, what we can do is we can use a command called ls, right? It stands for list, or more specifically, list segments. And all it's going to do is it's going to list the contents of the directory we're currently in. And I'll explain in a moment what I mean there. Let's just see what it looks like. All right, so I'm typing in ls. I'm going to hit enter. And I see desktop, downloads, pictures, templates, documents, right? A bunch of different folders right here. Now to explain what this means in the context of how we usually use computers, right? You're probably used to using computers by going to this icon right here, right? This file explorer, clicking on it, and then double clicking through all these different directories, right? To navigate around. We're going to do the same thing today, but only using the command line, right? We're not going to use the graphic user interface for it, right? So you see how we have this documents folder here, and we can double click into it, and then we can read this text file. We're going to do the same exact thing in our command line, right? So what I'm going to do, right, is as you can see here when I did ls, I see all of the same contents as I do on the left. That means that I'm in the same directory on the screen to the right as I am to the screen to the left. And I'm going to use a command called cd, or change directory, to go into it. So remember, if I just went into my documents directory on the left here using what we call the graphic user interface, or the GUI, what's the name of the directory that I should type into the right side here in order to get that to that same location? Right? You probably guessed it, right? Documents. Now, if you're wondering how I auto-completed there, I actually just hit the tab key after typing a couple letters in. That's something that's going to save us a lot of time, hassle when it comes to spelling, right? So just keep that in mind, right? But I'll type it out all the way just for the sake of keeping things well-paced. So to talk about what we're doing here, right? Before I did ls, and in the current directory I was in, we saw all of these contents. Now I'm using the command cd, which stands for change directory. I'm going to change directory and go into, as we see on the left here, my documents directory. I'm going to hit enter. Now I want you all to pause the video, right? And I want you all to guess what's going to happen when I enter ls again and hit the enter key, right? What's going to show? All right, so take a moment to pause the video. Well, welcome back, right? If you guess that you're going to see the readme.txt file like we do on the screen to the left, you're absolutely correct. I'm going to hit ls, and as we see readme.txt. Now, in order to read this document how we normally do, right, we're used to double clicking it and then it popping up here, right, the text. But we don't have that option in the command line. There's nothing to click here. So instead, I'm going to use the command cat, C-A-T, right? Cat, like a house cat. And then I'm going to type in the file I want to read, right? I'm going to put this readme.txt file in. So I'm going to type in read and hit tab to autocomplete and then hit enter, right? And as you see, the contents we're reading on the left are exactly the same as the contents we're reading on the right. Now, let's say I don't want this file anymore. I actually want to remove the file, right? I want to get rid of this readme.txt. I don't need it anymore. I want to clear up some space. What we can use is the rm command, right? So I'm going to type in rm, type in readme.txt, and I'm going to hit enter. And now I don't know if you all noticed, right? Feel free to rewind to see what just happened. But on my screen to the left, that file just disappeared, right? So using only my command line, I just deleted the file entirely, right? So using this rm command, which stands for remove. So we have just taught you all 4 commands. ls, which is list the contents of the current directory we're in. We learned cd, which is change directories. We learned cat, which is read file contents. And then last but not least, we learned rm, which stands for remove. Let's recreate the file we just deleted, right? I'm going to use a command called touch. I'm going to type in touch, and I'm going to type in readme.txt. What the touch command does is it actually is going to create a file with the name readme.txt. The only thing is that file is empty, right? So when I hit enter, pay very close attention to the screen on the left here. Right, as you see, readme.txt has now come back. I'm going to type in cat readme.txt. I want you all to guess, when I hit enter, what is this going to read? What is this going to print out? Right, take a moment to guess that. Right, when I type in cat readme.txt, what's going to happen? Okay, got your guesses? Let's see. When I hit enter, nothing happens. Why is that? Let's check on using the computer the way we usually do. Let's open it. It's because it's a blank file, right? We removed the file with text, and then we recreated an empty file with no text, right? So, touch, new command, right? Keep that in mind. As you're probably noticing, when it comes to command syntax, this is what we're seeing. We see the name of the command and then what we call an argument, right? The argument is what we are referring to. When I say remove, right, remove is the command, rm is the command. The argument is what I am referring to when I say rm, right? If I just said rm, like let's say I just typed in rm and hit enter, it's going to say missing operand or missing, basically argument. And the reason for that is it doesn't know what to remove. We need to specify it. However, if I type in rm readme.txt, it knows, okay, I'm running this command on this argument, right? And once again, check to the left, we see that file disappear. It's the same thing with touch. If I just type in touch and hit enter, it's going to say missing operand. In order for me to create an empty file, I actually need to name it, right? So I'm going to do touch. I'm going to name this empty file.txt and recreate that on the left here. So I want you all to take a moment. I want you all to practice creating files, deleting files, and I'm going to show us one more thing in just a second. So please take a moment to pause the screen. The goal is for you to create and delete a file in your documents folder, right? So try to navigate solely using your command line, right? Get into your documents folder and to do that. Thank you for tuning in. I will see you all in the next video. Hello and welcome back. So in the last video, I gave you the task of trying to create and delete a file in our documents directory. If you've not had a chance to do that, please pause the video now and attempt that. Right, as a quick reminder, the 2 commands you're going to need to use are going to be touch and rm, right, to do the creation and deletion process there. So please pause the video And once you get that done, we will segue into the next part of the video here. All right. Now that we had a moment to do that, let's talk about maybe some common issues we ran into. It may have been the case, I'm going to clear my screen by typing clear, hitting enter. It may have been the case that you all went into the wrong directory. Let's say I CD into desktop, right? And I hit enter, right? And I hit ls, right? Desktop is empty. There's nothing in here. How do I get out of my desktop directory? Well, what I could do is I could use a saved key, a saved keyword that Linux understands. I could do change directory, and instead of giving a name of the directory I want to change to, right, I can give double dots, right? What exactly does this mean? Basically, the first dot stands for, if I just put one dot, it stands for this current directory, which is my desktop directory. Double dot stands for the parent directory, right? So if you ever need to go one directory back, right, you would do cd ... to switch back to that parent directory. When I hit enter and ls again, right, we can see I'm now in the previous directory I just came from. To explain in a little bit more depth what I mean by this, right, when you switch directories and use cd, you can only switch to directories that are available to you given where you are, right? So when I did ls before, I see that desktop, documents, downloads, pictures, I could cd to all of these different directories. However, if there was another directory that was a couple layers deeper, I wouldn't be able to directly switch into that, right? So that's just something to keep mindful of, is that when it comes to directory navigation, you have to go step by step, right? And let me show you this, and feel free to not follow all these commands, right? I'm just going to check, or I'm just going to create a directory real quick to demonstrate my point. Let's do make directory. I'm going to do new dir. Okay. So what did I do? I made a directory. It's in my downloads folder, so I'm going to do ls. I just made a directory in my downloads folder called new dir. I'm going to try to cd to that. I'm going to try to change directories to new dir. When I hit enter, it's going to say no such file or directory. Why does it say that, right? I know new dir exists. Why is it telling me this? Well, it's telling me this because of the directory I'm currently in, right? I'm currently in a directory that doesn't see new dir. I actually have to go one layer deeper. So what I need to do instead, since I know new dir is in the downloads folder, I'm going to do cd, downloads, hit tab, and then new dir, right? In order for me to get into that directory, since it's one layer deeper, I need to specify this path here, right? I have to give the computer, right, a way to find what I'm actually specifying, what I'm looking for. Now when I hit enter, keep note, right, I now see, and you can tell by this blue extension to our tilde, I now see them in the downloads, new directory folder. To go back, I want us to guess. How do I go back to just the downloads folder? I don't want to be a new dir, right? Take a moment to pause and to guess. All right. If you guessed by doing cd ... you are correct, right? We can now see I have backspaced out of the new dir and back into the downloads. Let's do cd ... one more time. And as you see, I am back to our starting point. All right. Last thing I want to show us all for today is I'm going to show us how to print our working directory, how to copy files, and how to move files. So what I could do here, right, is if I do pwd, this stands for print working directory. If you're ever lost and you're not sure which directory you're in, you could do pwd and it will tell you, right? So right now, as we see, we are in the home Ryan directory, right? That's so we're in the home, right, Ryan directory. Let's go to documents. What I'm going to do is I'm going to switch directories now. I'm going to go cd, let's go to desktop, and I'm going to do pwd again, right? Now we can see I'm in the home Ryan desktop directory. So keep in mind, pwd is going to give us an indication of where we currently are in our system, right? It's a little bit harder for us to keep track of where we are because we don't have a graphic user interface with our terminal, right? So just keep that in mind, that this is a good way to work with that. Let me see, can I make this? Let's go back one. All right. Next up, two more commands, and we'll call it a wrap on this video. I'm going to do clear, right? Type in clear and hit enter to clear my screen. You could all do the same. I'm going to make a new file once again. I'm going to do touch, new file. file.txt. I'm now going to show you a command to copy new file, right? If I wanted to make an exact copy of this new file, what I could do is I could use the cp command. I name the file that I want to copy, and then I'm going to name where I'm sending it to. So the cp command is going to take in 2 arguments, unlike some of our other commands. It's taking in the file I want to copy and what I want to name the copied file, right? And I'm going to hit enter. Now if we go, let's look to desktop here, right? As you can see here, I now have 2 files on my desktop, right? If I type in ls to list the documents, I now have 2 files, and that means that it is successful, right? The cp command. This will also copy the contents of the files as well, so just keep that in mind. All right, last but not least, let's talk about the mv command, right? How do I rename files? Well, it's, as I just spoiled it, with the command called mv, right? Typically, this file is used for either moving files or renaming files, right? It can be used for both. So like, let's say I have new file here, right? And I want to move this to, let's say I want to move it to my documents folder. What I could do, or excuse me, let's make a new directory. I'm gonna make a new directory. Let's do instead of documents, let's just call it files. All right. So I just made a new directory. We'll go into more depth with mkdir, what exactly we're doing there. So do not feel afraid yet. My goal now is I'm going to move both of my files into this files directory, right, for good file organization. So what I'm going to do is I'm going to type in the mv command. This stands for move, right? And this can be used to either rename files or just move them. And I'm going to do new file.txt, and I'm going to move that into my files directory. All right. So I have mv, the file I want to move, where I want to move it. Now, what I get to do is I could actually change the name of this file. I'm going to name this old file.txt. So with this mv command, I'm actually doing 2 things. I'm moving the file and I'm also renaming it. And let's hit enter and observe what happens. As you see on the left here, my new file, it just disappeared, right? Where'd it go? Let's double click into here, right? It now has moved into that and has been renamed as old file, right? And if I type ls, as we see, it has disappeared here as well, right? We just see files, copied file. All right, I want you all to take a moment. If I wanted to move the copied file into this files, what would the syntax for that be? Take a moment to pause the video, write that down, and to think about that. All right, well, if you guessed mv copied file.txt and then just putting in files, you are correct. If I hit enter, as you see, the file has disappeared and both files now are in this new files directory. Before we close out the video, one thing I want us to notice, the name of copied file.txt did not change. That's because I did not specify a new name at the end here. All right, well, that is it for this video. Thank you for tuning in. Hopefully you've learned something about file navigation, file creation, file deletion, and then also copying and moving files. Right. I will tune in with you for the next video. Welcome back. So in the previous video, I showed you all how to create an empty file. I'm going to show you now how to create a non-empty file in a couple different ways, right? How do we fill this file with text? First off, let me close out. We don't need the graphic user interface anymore. We're going to use strictly the terminal now. So let me make this bigger. What we can do is I'm going to do ls, right? I'm going to see where I currently am. I'm going to go over to my documents folder to do this work. So cd documents, and I'm going to ls there. And I see there's an empty file. As we said before, right, in order to read files, we could use the cat command. So I'm going to do cat empty file, right? And we should see that there's nothing in it. What I'm going to show you all now is how to create a file with text in it. And there's a couple ways to do it. The first way is to use a text editor. So what I could do is I could use Nano or Vim or Emacs if you have that downloaded. We're really just going to focus on Nano and Vim for the purposes of this course. And I could use what is called a text editor. The best way to think of it if you're familiar with Windows is it's like Microsoft Word. If you're familiar with Mac, it's very similar to Pages, right? It's just going to be a little bit weirder on the UI or the user interface here. So all I have to do to use this text editor is type in Nano and then the name of the file. I'm going to name this text file.txt and hit enter. All right, now as you see, my terminal has changed, right? It looks a little bit different. Instead of being in my terminal, I'm actually now in what we call a text editor, right? So I could say, hello, this is Ryan. This file is not empty, right? Now you might be wondering, now how do I actually save this, right? I'm used to Microsoft Word where I hit File and Save and it does all that work for me, but how do I do that here? Well, if you look in the bottom left corner here, right, we can actually see some options, right? We see the exit option, we see the write option. And just to give you a little bit of a hint here, when it comes to computers, specifically, terminals, when they say write, what they really mean is save. This caret next to the O here is actually standing for control. So in order to save, I'm going to do control O. It's going to say write name to, or file name to write to, text file.txt. I'm going to confirm that and hit enter. And I've now saved my file, right? By doing control O, I'm going to do that again and hitting enter. The contents that I just typed out are now saved. Now to exit out, I want you all to take a guess. What do I have to do? Right, look in this bottom bar. What do I have to do? Well, if you guessed Control X, you were correct. I'm going to do Control X, and I've quit out. Now let's read the text file we just created. I'm going to do cat text file.txt. And once again, if you're wondering how am I typing this so fast, I'm not. I'm just hitting tab as soon as I put in the first couple letters and letting the terminal autocomplete for me here. Hit enter. Right, we see right here, this is the text I just put in. Let's use a different text editor. I just used Nano, right, and we gave the file name. Let's use Vim, and this file name is going to be textfile2.txt. I'm going to hit enter. Right, once again, that command is Vim textfile2.txt. Now, for our version of Ubuntu, right, this is actually not going to be native. It's not going to be downloaded by default, but that's okay, right? We actually see some commands here telling us how to download, right? And we're going to use the apt command quite a bit when it comes to getting these tools, right? So I'm actually going to just copy and paste this command for now. We'll go into this later on, but to go into depth of what this command is doing, sudo stands for super user do. The best way to think about it is if you ever needed administrator privileges on your Windows machine to allow a download, right? This is the same concept here for Linux, right? We're downloading a program, and because of that, we need to do it as a super user, right? So sudo stands for super user do. Apt, this is the command we're going to use to actually install. Install is the keyword we're giving, and then Vim lastly is the program. I'm going to hit enter. Now, I actually have to type in my password because when I use super user do or the sudo command, it wants to make sure that I actually have permission to do this. And as we see, it is now downloading. You'll be hit with this prompt, Y or N. I'm just going to type uppercase Y and hit yes. I'm going to let that run for a minute or two. Should be relatively quick. So if you let this spin up, right, congratulations, you have now downloaded your first command using the sudo apt command, right? Or we use both sudo and apt. So now let me clear my screen. Instead of rewriting the Vim command I did before, I'm actually just going to hit the up arrow key, right? Show you a little shortcut. I'm going to hit the up arrow, right? You can see the up and down arrow key to go back to that Vim command I just had. And I'm going to do vim textfile2.txt again. I'm going to see if I still get an error. Oh, sorry, I accidentally added that slash at the end. If you're wondering how I quit out of that, I just did Control C. Now, when I hit enter, right, we're now in the Vim text editor. You might be wondering, well, I don't see those helpful commands at the bottom. What do I do here? So this text editor is much less user-friendly, right? So be cautious of that. In order for us to quit out of this editor, we actually have to hit the escape key, shift colon, right? You can see the colon actually generate here, and then the Q key if we wanted to escape out. And then lastly, enter. Right? It's much less beginner-friendly, to be quite frank, when it comes to Vim. I'm going to reopen this file, and let's add some text. Another thing you're noticing, if you try to write hello, right? I don't know if you actually heard it actually didn't start typing until I accidentally hit a key, right? Let me show you this again. Oop. Let's do that. Oop. Q. Right. I don't know if you all noticed, but when I hit keys, right, I'm hitting like A, S, D, F, right? It's actually giving me an error. It didn't seem like it was typing at first until it changed it to what's called insert mode down here. To explain what that means, and I'm going to clear out this file one more time. In order for us to actually text in this Vim editor, what we need to do is we have to hit the I key to put the editor into what they call insert mode. Once we're in insert mode, I can freely type now. I can do hello, how are you? I am Ryan. Similar to Nano, we need to use a specific command in order to save out of this. However, for Vim, it's much different. First, I need to hit the escape key. This is going to stop insert mode, so I'm going to hit escape. I'm then going to hit the shift key, the colon key, right? We see this colon, and then WQ. All right. Using what we know about Nano, what do we think the W stands for if I'm trying to save and quit out of this program? What does the W stand for? Give me a guess. All right. Well, if you guessed right, you are correct, or you are right. Right? So, WQ, right, stands for write and then quit. Now I'm going to hit enter. And this now means if I do ls, we have all three text files here. This is the one I created in Nano. This is the one created in Vim. This is the one I created with Touch. That is empty. So let's cat text file 2.txt. Hello, how are you? I'm Ryan. Once again, let's go back into Vim, right? Because it's confusing. I'm gonna write over this command. I want you all to go back into the Vim file that you just created. Try to change this. Instead of saying, hello, how are you? I'm Ryan. Let's delete all this. I'm going to hit the I key for insert mode. I'm going to delete all this and put in, this is my first file. Once again, pause the video. Try to save and quit without my assistance. I'm going to give you all a second to do so. Okay, welcome back. The way to do it, right, is we hit the escape key to escape insert mode. Shift colon WQ. If I just put a Q, I'd quit without saving. The W stands for write or save, and then the Q stands for quit. If I just wanted to save, I could just put the W here, and that will save it for me, right? But I want to do both, WQ. And now if I cat this file, text file 2.txt, you will see the contents are now different. All right, well, that was modifying files with text editors. The very last thing I want to show is there's actually another way to create files. There's a command called echo that we can use, and it will actually output, basically output text into a file. Right, so let's show that. I'm going to do Control L to clear my screen. You could also just type in the word clear and hit enter. This next command is called echo. And what echo does is whatever I put after echo, let's do echo, I'm going to do quotations, hello, will print out to my screen. However, if I do not redirect this output anywhere, this doesn't save, right? I'm just screaming into this empty cave, hello, right? And it's not actually going anywhere. It's not being saved or anything, right? However, what we can do is we can modify this command a little bit. So I put echo, I gave it the argument hello, which meant to scream into the void, hello. But what I could do here is I could use a greater than sign and let's put echo text.txt. To explain what I'm doing, I'm using the command echo. I'm putting in the argument hello, right? So this is the actual text. And I'm redirecting this output, right? The output of this command into a file called echo text.txt, right? The best way to think of it, do you see how the alligator mouth is pointing to, right? Like it's almost like an arrow pointing at echo text.txt. It's taking the content from the command on the left and it's cramming it into the file that we just specified on the right. So if I hit enter and I do cat echo text.txt, I want you all to take a guess. What are we going to see here? All right. If you guessed hello, you are correct. Hello to you. So echo, we have two ways to use it, right? Or we have a lot of ways to use it, but two ways that I'm showing right now. The first way is to use it and just scream into a cave, right? If you echo in a forest and no one's around to hear it, did you really echo, right? So that's the first way to use it. The second way is to redirect that output, right? So this is what output means, to redirect this output and to throw it into this echo text.txt file. Now if I have ls, we now see I have 4 files. Once again, I made this file, this empty file with touch, right? The command made for making empty files. I made this with nano. I'm actually going to rename this text file. Right? Feel free to pause and rename this on your own. I'm going to do nano file.txt, name text file 2. I'm going to rename this to vim file.txt so it's a bit more clear. Control L. So I have 4 files that we just created. I have the file we made with nano, the one we made with vim, the one we made with touch, and lastly, the one we made with echo. So that's how to create files, how to cram stuff in it, right? How to create files that are not just empty, right, but also have contents in it. So in the next video, I'm going to be showing you how, with this skill, we'll actually be able to write our first couple scripts, right, and be able to take it from there. So thank you all for tuning in. I will talk to you all in the next video. Hello and welcome back. So today we're going to talk you all through some basic scripting. Right? Why do we need to learn scripting? Well, there's going to be tedious tasks that you're going to want to automate. Right? And if you're a systems administrator, there's going to be tedious tasks that you'll need to automate. Right? It's just not feasible for someone to be around 24/7. In order to automate those tasks, you have to understand how to do what's called bash scripting. So for this video, we're going to show you how to do it just in the command line and one-liners, right? But for the following video, we're actually going to use some previous knowledge we now have on text editors from the video before, and we're going to write scripts using those text editors, right? So let's jump in. First up, I'm going to open up my terminal. I'm going to make it full screen, and I'm going to hit Control-Shift+++ to make the screen a little bit more readable. Okay, so this is how we're going to structure the lesson for today, or structure this portion of learning. I'm going to write a very complicated command. You all are going to guess what it does, and then we're going to reverse engineer it. So for our first script, I'm going to do for. Let's do count in 1.100 semicolon do echo $count semicolon done. All right. So before I run this command, right, or run this script, I want you all to guess what it's about to do. Right? So a couple of hints here, right? What do we think this does? We know what echo does, right? But it has $count. What does that mean, right? I want us to try to think about these things. So I'll give a second. Feel free to pause the video and to write down what you think will happen. All right. Well, if you guess that it's going to print out the numbers 1 through 100 in order, you are correct, right? If we scroll up, we could see that one by one, this, what we call for loop, printed the number 1, and then the number 2, and then the number 3, and 4, and 5, and so on, right? All the way up until 100. Now, before we reverse engineer this string, I'm going to hit the up arrow key to get my command back. What do you all think would happen if I change the 100 to 300, and let's say the 1 to, let's do 97? Right, what do you all think would happen here? What's it going to print out? So take a moment to guess. All right, let's hit enter. Let's see what happens. Okay, it looks like it printed up to 300, but where did it start? Let me scroll all the way up. All right. Well, if you guessed that the starting number that it would print is 97 and the ending number is 300, then you are correct. So to reverse engineer, to break this down a bit, let's jump over to to a tool I like to use called Excalidraw. So we can see I took the command that we ran before. Let's change this just 1 to 100 so it's exactly the same. So we took that command that I used before and we broke it down into 3 separate sections. So just to give you some background, right, this type of script, it's called the for loop, right? And basically what it's going to do is we're going to specify how many times it needs to do something. It's going to do that thing that amount of times, and once it's done, it's going to exit the loop. It's going to end. Right? There's really 3 main sections for this for loop. Right? The first section, let's make this large text. How many times we are doing the command, right? So this first section, it's responsible for specifying how many times we're doing the command, right? As you all saw before, we could find that out by looking at this, right? We see our range here is 1 dot dot dot, or excuse me, just dot dot, 1 dot dot 100, which means that this is going to occur 100 times, or at least within that range of 1 to 100, counting 1 inclusively, right? So this is how many times we do the command. The other thing it does, right, and this is going to be the trickier part to grasp, is it's setting a variable, right? What do I mean by setting a variable? Well, this count right here, this count keyword, is actually special. What's going to happen is the first time this for loop runs, right? Keep in mind this loop is running 100 times. The first time this for loop runs, this count is going to be equal to 1. The second time this for loop runs, count is going to be equal to 2, right? And this is going to happen all the way up to 100, right? Keep this in mind because this is important for section number 2, right, which we are about to explain now. Right, so section 1, as I just said, it's talking about how many times we are going to do the command. And it's also setting up a variable. Keep in mind here that this name here is arbitrary. I could change the name to, I could have done incrementer, counter, right? I could have done pineapple. It would have done all the same things. It actually wouldn't have changed the way this would have worked. The only thing we have to ensure is that the variable over here matches when we call it over here. Right? And that's actually going to perfectly segue us into explaining section number 2 and what that does in this command. So, section number 2 here, right? What is this doing? Well, instead of using this for keyword, right? Keep in mind we have a couple keywords that we have to start each of these with. Let me see. Can I change? We're going to put this around the keywords. Okay, so we have the for keyword and we have the do keyword, right? So this do keyword, what is it doing, right? Well, what it's doing is it's saying what command we want to run, right? And then we're running echo count. So before we said how many times we're doing something, this is us specifying what that thing is, right? So what we're doing is we're echoing, right? So this is, the do keyword starts this section, right? In this situation, we are echoing the count variable, right? So keep in mind, as I said before, count the first time this loop runs is going to be equal to 1, the second time 2, third time 3, so on and so forth, right? And really all that's happening, if we go back to the terminal here, right, let's run the previous command. When I do a command like this, all that's really happening is it's basically the same exact thing as if I did this. Echo 1, echo 2, echo 3, right? And if I did that 100 times. Now, as you know, and you can already see the efficiency of this, right? To echo up to 100 would take me probably like 10 minutes, right? Or maybe a couple minutes. You can imagine how that might scale up, right? If I had to echo up to 1,000,000 for whatever reason, maybe my boss gave me that task, who knows, right? And that's the power of scripting here, right? But the main thing I want us to understand is that the for loop we just wrote and that we're dissecting right now is just trying to do this thing, right? This command 100 times and to completely automate the process of it run, right? Without human intervention, right? Once again, to show it doing that without any human interaction beyond me just programming this line, it is going to print from 1 to 100, right? And here we are. So let's jump back to our explanation. So second section here, this do command, right? Keyword starts the section. In the situation, we are echoing the count variable. Once again, count, that is an arbitrary name. I could have named it incrementer, could have named it pineapple pizza. I could have named it dog, cat, right? And it would do the same thing. The other thing we have to recognize is there's another, in this case, it's a key symbol here, right? So I'm going to put the diamonds around the things that are going to seem weird and counterintuitive to us. In order for us to properly call the count variable, we need to put a $sign in front of it. That is Linux's way of understanding, okay, I'm looking at a variable and not just another keyword, right? What separates this count that I made up from their sanctioned do, right, or their, I guess, specified do keyword is this $sign. It explains the difference, right, to Kali, or excuse me, not Kali, to our Linux machine in this situation. So I'm in the cybersecurity mindset with the Kali VM. So let's go back to it. All right, let me show you all something. All right, I'm going to change count to, I'm going to name it arbitrary. All I have to do is make sure that this matches the variable we set up here. I think I spelt it right. I guess I did not. Let's see, let's clear it. Let's check my spelling. RB, oh, I do arbitrary. So as you can tell, I'm in tech, not because I can spell, but because I can code. So as you see, the same exact thing just occurred, right? Just with different variable names now, right? It went from 1 to 100. It printed it out line by line, right? And was able to do that. Quick little cool tangent, right? If you want to take out the fact that it starts the new number on each line, right? You could actually do echo-n, right? This will take out new lines, right? And as you can see, it prints the numbers 1 through 100 all in one sitting here with no new lines. It's not hitting the enter key essentially, right? Explained that a little bit in a previous video, like the fact that a new line is technically a character. So this is our script. Thank you for tuning in. I will see you all in the next video. Hello and welcome back. So in the last video, we showed you a simple script that is going to go and print out the numbers 1 through 100 using this one-line command. During this video, we're going to show you some more complex tasks that we can do with this for loop. So stay tuned. Now let's use it for something that may be more interesting to us. Let's say I needed to create 10 files and I had to do it quickly. Well, first, before I do any of that, I'm actually going to create some file structure. So I'm not just filling up my root directory here. I'm going to go into my documents. So I'm going to cd or change directory to documents. I'm going to make a directory, so mkdir, and I'm going to name this loop files. I'm then going to ls to make sure that directory is here, and I see it right there. I'm going to change directories into loop files. ls, and we see an empty directory. So now, right, I want you all to try to write a loop that will make 100 files, each called file 1, or excuse me, make 10 files, called file 1, file 2, file 3, all the way up to file 10. Right? I want you to write a for loop similar to how we just did with the echo command, except for file creation. Right? So make 10 empty files with the naming convention file 1, file 2, file 3, file 4, all the way up to 10. Feel free to pause the video and give that a shot. Right? Make sure you're doing this in a directory that you're okay with filling up with needless stuff. Right? Once again, you do not want to fill up your root directory. So please make a specific directory for this task. All right. Well, if you took some time to do that, welcome back. The command we're going to do is for. Let's do, I'm going to do index, right? Once again, showing that the names here are arbitrary. I'm going to make my range 1.10 because I want this to occur 10 times. I'm going to do a semicolon because as we said before, and as we showed in Excalidraw, semicolons are the delimiters that separate each of these sections. I'm now going to do my do command. I'm going to type in do, and I'm going to talk about what I need to do. So when it comes to making empty files, as we've talked about previously in our Linux introduction, that is going to be the touch command, right? This is the command to make empty files. The trick to this problem, though, is how do we make these files have an incrementing name, right? And the way to do that is actually by putting the word file, $index, right? And we'll see in just a moment what's going to happen. I'm going to make a little bit smaller so we can fit the full line. I'm going to do another semicolon and done to specify that after 10 iterations, my loop will end. Okay. So let's see. Yep. Quick thing. Forgot a little keyword here, right? Just make sure you put the in command, right, or the in keyword in between index and then where you're more aptly your value, your variable, and between your range, right? And now we should be good to go. So now if I ls, right, let's see what happened. I now have from file 1 to file 10, right? And it unfortunately didn't organize it very well. It didn't organize it sequentially, right? It just went file 1, 10, 2, 3, 4, 5, 6, right? The reason for that is it's viewing the 1 in front, right, as sequential, right? It's not looking at the 10 as a whole number. It's looking at 1 as basically alphabetically, 1 technically. The best way to put it is an alphabet, right? 10 is technically before 2 is the best way to put that, right? And it puts it sequentially in that order, right? But as we see here, we have just created 10 files, all of which, if I cat them, are going to be empty, right? Which is pretty cool, right? We just automated a task that would have taken us minutes to do, right? Maybe hours, depending on what you have to put in these. And in addition to that, you can see how the scaling really occurs here, right? All I'd have to do to make this 10,000, right, is to just change it to 10,000. It's going to take a little bit longer, right? It's going to process all of this. My VM's going to hate me for a second because I just gave it a lot of work. But when we LS, you now see 10,000, right? And keep in mind, it's pretty cool actually to see the number system and how they organize this all sequentially, right? 508, 5080, or 5080, 5081, right? Pretty interesting to see how they put it in technically alphabetical order, but it's not numeric order. Right, so pretty cool. We just wrote a script that we can customize, right? And depending on the task that we're given, right, we can make fit the task. Now, I'm going to remove all of these. So I'm going to do rm star. Once again, make sure you are in the right directory when you do this. We're going to talk a little bit more about wildcards, regular expression in a later video. All you need to know for rm star is I'm saying to delete everything in this directory. When I ls, I got rid of all my hard work there. Right? RM star is just saying, hey, I want you to remove, and the star means everything. Remove everything. Let's dissect why this worked. I'm going to change this back to 10. And then we will call it a night with the video and move on to the next section. Right? So what's happening here, right? For index 1 and 10, let's take this into Excalidraw, right? Just so we can print it out. Scroll down a bit, print it. Great. What's happening, right, is on the first iteration, index is equal to 1, right? So it's actually going to be touch file 1. On the second iteration, index is equal to 2, right? So it's going to be touch file 2, right? File 2. Third iteration, 3, and you get the drill, right? The weird part here, right, is that we can take the name, right? We can take a regular name and append a variable at the end of it, and it'll basically just spit it onto the end. Right, it'll take it and just glue it, right? It'll hot glue it to the end of whatever the name of that file was, and we can see it incrementing as we hoped it would. So that is it for this section of the video. This is our first introduction to for loops, to scripting. The next video, we're going to show you all how to put it into an actual file, right? Ideally, you don't want to have to type this out every single time you want to run these commands. So we're going to make a file that every single time you run it will perform these actions for us, and will simplify our lives. So thank you for tuning in for this video, and I will see you in the next. Hello and welcome. So last video, we showed you all how to do these one-liners, right? How to do bash scripting in our terminal. Today, we're going to do something somewhat similar, but instead of using our terminal, right, and writing these one lines of code, what we're going to do is we're going to open up a text file, throw our code in that text file, turn that text file into what we call an executable, right? And then we're going to run our code from there. So to get started, we're going to do a quick little recap. We have our code here. It increments between 1 to 10, and each time it increments, it creates a file with the number that we are currently indexed on at the end. Right? And just to show that, I'm not going to run it in here. I'm actually going to make a new directory. Right? Remember, as we go through this course, having a clean file hierarchy or directory system is important, just to make sure that we're keeping everything in one spot. Do mkdir for make directory. I'm going to do scripts. Make a directory called scripts. When I ls, right, note that this directory is blue, right? So we know, hey, this is a directory, not just any text file, right? We actually see that Ubuntu will color code it for us, which is pretty nice. I'm going to cd into my scripts directory, ls, and as we see, it is empty. Now let's get back that line of code we had before, right? And if you're wondering what I'm doing, I'm just hitting the up arrow key, and it's going through my history, right? Just to save me some time on the typing. So here we have for index, right? This is the variable we're setting up, just a little bit of review from last video. In the range we're going to increment, so this loop is going to happen 10 times, right? Our for loop is going to occur 10 times. Do touch, this is our command to create an empty file, and name that file in whatever the index we're currently on. Right? And as you could probably guess, when I hit enter, what's going to happen is in this directory, we're going to have file 1, file 2, file 3, all the way up to file 10 created. So let's see that happen. All right, if I type ls, you see that here. Once again, as I noted before, unfortunately, the way it organizes the files, it's a little weird, right? You would think it'd be file 1 to 10, right, with 10 being the greatest number and therefore all the way to the right here. But it actually does it alphabetically, which means that file 10 alphabetically comes before file 2. All right, so that's enough for review there. I'm going to rm start to clear our directory here. I'm going to do ls, and you see it's empty once again. Let's do something similar, right? But instead, let's use a text file, right? What are the benefits of doing this? Well, if you want to automate these processes, right, and you don't want to have to type in this every single time you want to create 10 files, right, you could just make a script, right? And you could either have an automated process that at a given point in time every day runs that script, or you yourself could run it and it saves us a lot of time. So I'm going to do Control U to clean out that line. I'm going to use one of the text editors that we learned a couple videos back. I'm going to use Nano. Right? Why am I using Nano instead of Vim? It's a little bit easier for beginners to pick up, right? But it's really just personal preference. Both of these will work for the purposes of this lesson. So I'm going to do Nano, and I'm going to name my script. Right? So Nano is our text editing command. This is the name of the text I'm creating. Okay. First and foremost, for us to create a script, right, a bash script using Nano, Vim, gedit, Emacs, right, whatever you choose as your text editor there, we need to actually be able to signal to our system, hey, this isn't just any text file, this is actually a script. And the way we do that is by using what's called an interpreter, right? And I will show you what I mean by that. I'm going to do #, exclamation point. We call this the shebang, /, and then I'm going to give the path to my bash scripting, /bin, /bash. Ooh, bash g, bash. Now, I don't want you all to get too caught up in what this means, right? Just know that in order for your text file to be read as a script, you need to include this in every line, right? So we have shebang, bin bash, right? And now when we exit out of our program, right, there's going to be one other thing we'll need to do, but now our computer will know, hey, this isn't just any regular text file. Now let's put some code here. I'm going to do echo hello world. Now, if this was a normal text file, right, this wouldn't matter, right? Hello world would, if I catted this, it would just be spat out the way I put it in here. But instead, I'm going to show you all actually how to run the script and have it treated as an executable. So now that we have typed this in, we're going to do Control X and then Y and hit Enter to save and to quit the program. And we now have our script called MyScript. Now, as you probably noticed, it's the same color as text files. And the reason for that is there's actually one more step we have to take before we can run this file. And we have to change the permissions of it, right? And what do I mean by that? If we type in ls space -l, right? Remember, -l stands for long listing. It's basically ls, but more details. We can actually see the executable permissions for our script right here, right? Or excuse me, just the permissions in general for our script. And as you see, we have read-write permissions, read-write, read permissions, right? And keep in mind, later on in the course, we'll break this down. It's called UGO notation. We'll break this down with even more depth. For now, all you need to know, right, is that this script currently does not have permissions to be executed. So what we need to do before we can run the script is we have to do a command called chmod. What chmod does is it will modify the permissions for our script here, right? And I could add the read permissions, the write permissions, but in this case, I'm going to be adding the executable permissions to our script. So I'm going to do chmod plus to signal that I'm adding permissions, X, and then my script. I'm going to hit tab. Oh, I got to make sure I got the caps right. Hit tab to autocomplete there. So this command right here is saying, hey, I want you to change the permissions of my script and add the executable permission at the end. Now when I hit enter and I do ls-l again, we see not only has our permissions changed, right? We have X, right, for executable now as a permission, right, where we didn't have that before. But also the color of our file name has changed, right? It's now green. Now, last step here, to run this script that we have just wrote, I could do ./my, hitting tab once again, script, and hit enter. Dot is saying, hey, run this from the current directory. / is saying, hey, treat this as, basically a script, right? And we see hello world is printed out, right? Which is what our code was meant to do. So that is segment 1 of scripting using a text editor instead of just our command line here. We're going to be jumping into some more complicated scripts in the next video. Hello. For this video, we're going to go into scripting a little bit more. Instead of just taking a static script that's non-interactive with the user, right? What we're actually going to do today is we're going to program a script that will take in what we call arguments from the user, use them in the script, right? And we'll actually change the behavior of our program, right? So let's dive right in. First up, I'm going to do Nano, right? Our text editor. You could use Vim, Emacs, gedit, whatever you like. Nano, and I'm going to do var script. So that opens up our text editor here. First step, always, is to start with our interpreter line, right? To start with the shebang /bin/bash, right? To make sure that our system knows, hey, this isn't just any text file. This is actually a script that we're going to be using. So now, and this is the part that's going to be new. We've seen variables before, right? But I'm going to show you how to assign variables in scripts like these, and then also how to assign them values based off user input. So what I'm going to do is I'm going to put the word name equals, and I'm going to do $1. All this line is saying is I'm going to create a variable called name, and I'm going to set it equal to the first argument that a user gives my script. Next up, I'm going to do, let's do age. I'll do age equals $2, right? And as you probably guessed, right, this is going to take the second argument that the user gives our script, and it's going to assign that to age. Now what I'm going to do is I'm going to do echo, right? So this is our command, quotations, right? So echo quotations, and I'm going to do $1, right? So what I'm doing is I'm going to take whatever the user inputs as their name, I'm going to print it out here. I'm going to put is $2 years old. Now before we run this script, right, and we chmod plus exit and then run it, right, I want you all to guess what's going to happen, right? So take a minute to guess, right? Feel free to pause the video. So to quit out of this and to save, I'm going to do Control X. It's going to say save modified buffer, Y for yes, enter to quit out, right? And before I do anything, I'm going to add the executable, mistyped, add the executable permission to var script here. So chmod plus X on var script. Right, so we have ls here. Now let's run this program without any arguments added, right? So I'm going to do dot for this current directory, / and then my script name, var script. I'm going to run it. And as you see here, it prints out blank is blank years old, right? And the reason for that is I didn't give any arguments, right? So let's use the program the way it was intended to be used. I'm going to do my first argument, which is Ryan, and then the second argument, which is the age, and I'm going to hit enter, right? And as you can see here, what happened was my script took this, right, called it $1, assigned it to the name variable, right, and then printed out the age and appended it all here. For this, let's actually see if we could split screen this real quick, right? It's going to be a little bit more interesting to see these side to side. Let's do new window. To split screen, all I'm doing is dragging them to different parts. Let's cd to documents, cd to scripts. I'm going to do nano var script so we could see the code and then see what's actually running. Okay, clear out here, get a little bit smaller, rerun. So on the left, we have me using the script. On the right, we have the script itself. As you can see here, right, the colors have actually changed now that we've added executable permissions, right, now that the interpreter has read this line as a bash script, right? We see that in red are our inputs, right, $1, $2. In blue is the command echo, right, the echo command. And then last but not least, in yellow is the string I'm printing out, right? So the way this script works, right, is $1 is looking for the first argument that I give var script, right? In that case, that is Ryan. It's then putting Ryan here, so it's going to do Ryan is, and then it's going to take the second argument I'm giving the script, right, which in this case is age, right? So it's going to be Ryan is, and then the age, right, which I gave 1,000, and lastly years old. Now what you might be wondering, right, is why why am I using $1, $2 again? Why don't I just use the variable names? If you're wondering that, awesome. I just want to show you that it is interchangeable. What we could do here, right, since I'm assigning name, right, or I'm assigning $1 to name, instead of using 1 and 2 again, right, the variable delimiters here, right, or excuse me, the argument delimiters, what I could do is I could do $name instead and $age. Right, you might be wondering, why is it beneficial to use this instead of $1, 2, 3, up to, like, millions and millions maybe? The reason for that is it's a little bit more clear what we're trying to do, right? If someone else is reading your bash script, it makes more sense to see $name than it does $1, right? They won't know what you're asking for, right? So let's quit out of this. I'm going to save it. I'm actually going to kill this terminal. Actually, no, we'll bring it back. I think it's helpful to see the script. I'm going to rerun my script, right? As you can see, it's functioning identical, right? It's functioning exactly the same way, right? So once again, let me CD here, there. Once again, once I set this, what we call variable, equal to this argument, right, the name variable and the actual argument are now interchangeable. Keep in mind, when it comes to variables, the way we specify the fact that we're using a variable instead of just name is with these $signs, right? So if I took $sign out here, I'm going to do Control X to save, Y, quit out, I'll reopen it, right, and rerun it. You're going to see that I'm actually going to print name literally and not the actual variable here, right? So we're going to see name is 1,000 years old. So you need the $sign in our script for it to be read correctly here. Right? So let's get that $sign there. Okay. So that is variables, right? And using variables with our bash scripts, as well as also using in arguments, right? User arguments that we provide the script. In the next video, we're going to talk about how to do for loops in this sort of structure. It's going to be a little bit different than what we've seen on the single command line, right, when we did those one-liners, but it should still be mostly similar. So I'll see you all in the next video. Hello and welcome back. For this video, we're going to show you how to do our for loop that we had showed previously, but instead of doing it in that one-liner as we had showed it before, we're going to do it in a script this time. So I'm going to do nano, and I'm going to name this one for loop script and hit enter. As always, we start off with shebang, bin, bash, right? By now we should probably have that memorized, right? As we write more and more scripts, a lot of these things will start to be committed to memory, which is pretty cool. To start off, it's going to look almost identical to what we did before. The only difference is instead of using semicolons to separate the different sections, if you remember, right, the for, the do, and the done section, what we're going to do is we're going to use our indents, right? We're actually going to do a new line to show that. So I'm going to do for I, or let's name it index, right? Remember, this is our variable name, in 1.100. And before I continue forward, I'm noticing that there aren't any colors with my code, right? So it's not really giving me too much feedback. I'm actually going to save out of this file, and you're going to notice something when I reopen this file. The colors are going to be added, right? The reason for that is once Ubuntu has a second to save the file, recognize that this is a bash script, right? It can actually color code this for us. Right, so we have our for, right? So this is going to be, and I will comment this, this is going to be specifying how many times our or loop is running. If you're wondering what I just did here with this hashtag, this is actually what we call a comment. This is my ability to put notes in that don't affect the code itself, right? So if somebody else is reading my script, they might have a better understanding of what I'm trying to do, right? So keep in mind anything that's in this light blue here, right, and comes after a single hashtag, that's actually not going to impact our script at all, right? So that's specifying how many times we're doing the thing. I'm then going to type the do command in. I'm going to hit enter one more time, tab. Let's do echo $sign to specify that I want to use a variable, our variable name index, right, and we see in red, right, that is how variables are represented. I'm going to hit enter, and then lastly, done. Right? So do this block is signaling what we are going to do. To comment this, we are echoing the current value of index in the loop, right? And as we know, when I run this, this is going to print from 1 to 100 all of those numbers, right? It's going to print first 1, then 2, then 3, then 4. So let's see that happen. Right, I'm going to purposely make this not run right off the bat. Let's try running it right here. I'm going to get a permission denied error, right? So I'm going to give you all a second to figure out, why is this permission denied? What's the one step I'm missing before I can actually run this as a script? So feel free to pause the video and try to figure that out and fix this issue. Well, if you guessed that we did not add the executable permissions, you are correct, right? We need to chmod plus x on our for loop script and hit enter. Now when I run this one more time, you will see that our script is running as usual. Let's jump back into the script and make one more change. I'm actually going to do the echo-n option, right? Options are represented in our script as purple. And what this option will do is, instead of printing each number on a new line, it's going to print it all on the same line, right? And we're going to see what that looks like right here. I'm going to do Control X, Y, Enter to save and quit out. And as you can see, it is quite a mess, but from numbers 1 to 100, we have printed them all out on the same line, all the way up to 100. All right, well, thank you for tuning in. The next thing we're going to cover with scripting is exit statuses, right? So different exit status codes ranging from 0 to 255 and what they mean, and then also showing how you can program your scripts to be intelligent with those exit status codes, right? How do we make it so that if we hit an error, right, we are able to intercept that and not have it crash our whole script? So tune in for the next video. I'll see you all in a little bit. Welcome. So for this video, what we're going to talk about is input-output redirection for Linux. So first, what I'm going to do, I'm going to make a new folder with mkdir. I'm going to name this IO test. Looks like IoT test, right? Well, that works for me. All right. Next up, what I'm going to do is I'm going to show you what I mean when I talk about input and output, right? Let's say I do echo and I use the quintessential hello world, right? And I hit enter. What you all might notice is that this doesn't save this output to a file, right? All it does is it spits it out to our console and it doesn't save it, right? So when we do ls, we see that my directory is still empty. But if I hit the up arrow key a couple times to get my command back, what I could do here is I could actually use input-output redirection to save this to a file. So I'm going to use the greater than symbol, or you all may know it as the alligator symbol pointing to the left, right? And the best way to remember it is that the point of the symbol here, right, the point of the triangle, is going to be pointing at the file that that information is moving towards, right? I'm going to put this into hello world.txt. What you're going to notice is when I hit enter, right, this echo hello world, right, the output of this, right, which is just hello world, will be saved to this txt file, right? So when I hit enter, you notice a couple things, right? One, it did not print this to our terminal, right? It didn't spit that out. And two, when I do ls, you notice that there's a new text file that wasn't here previously, right? And if I cat this file, you're going to see very quickly that instead of shooting this out to our command line, what has happened is this command, right, this line, has actually taken the echo hello world and moved that output into hello world.txt. Now, if we wanted to overwrite this, I'm going to pull my command back up. All I'd have to do is change this output. This is to overwrite hello world, right? Now when I hit enter, once again, it's not going to print anything out to the terminal here, but instead it's going to take the output from this command and it's going to put it into hello world.txt. Right, so when I hit enter, once again, it's not printing to the terminal, but when I cat hello world, we're going to see the contents are different. So now you might be wondering, if I just wanted to append text to a file, right, I didn't want to overwrite that text file every single time, how would I do that? Well, the way, and I'm going to get my command back, the way to do that would be by using the double caret sign, right, or the double alligator mouth, right, or greater than sign, depending on what your favorite way to represent that symbol is. Right. I'm going to change this to this text is appended to the end of the file. So what's going to happen when I click enter here, or what's going to happen once again, is instead of this overwriting the file this time, right, and replacing it with this new text, because of the fact I did the double greater than sign, it's actually going to take my text and slap it onto the end of that file, right? And I'll show you what I mean in just a second. I'm going to hit enter, and I'm going to cat hello world.txt once again, right? And you can see here are the previous contents of the file, right? They're still in the file, right? But this is the first thing I added. And appended to the end is the text that I have just appended, right? So pretty interesting. So far for input and output, we've learned two different symbols that we can use. This is to overwrite any text file, right, that already exists, or to create a new text file and fill it with the contents of whatever it is that your command is doing. And this right here is to append, right? So as not to overwrite the contents, but rather to append the new contents onto the end. Now this works for a lot of different commands, right? Let's say I do ls, right? I could actually do ls greater than sign. I'm going to name this directory contents.txt. And as you could guess, right, this output is going to be saved into this file, right? And when I cat directory contents.txt, you're going to see that the contents, right? And ironically, directory contents has been added to this, right, to our ls. But the contents of our directory here, right, is actually now in this txt file, right? So pretty cool stuff. If we wanted to append to this, right, let's say I wanted to append, right, ls. I want you to pause the video and to guess what this is going to look like when I cat this file, right, after appending ls's output once again. All right, let's check it out. So I'm going to run that command, right? Keep in mind, this isn't overwriting the contents, this is appending. So let's rerun this. And as you see, instead of overwriting the previous contents, we actually have created a little bit of redundancy and have appended the same context to the end of this text file. Right? However, this is not the only thing we can do with input-output redirection. We can also redirect error messages, right? So let's say I do something like, let's do cd fake directory. I'm going to try to switch directories to a directory that doesn't exist. Right? I can actually get an error message. Now, if I try to take this error message output and save it to a standard file, let's just name this file test.txt, you're going to see we actually get an error. And when I ls, right, and do cat test.txt, right, there's actually nothing saved to it, right? So this output actually was not saved. However, we can overwrite that by using the number 2. Right? So I'm going to pull back my previous command, the one that didn't work, right? The one that wasn't able to print, or excuse me, to put this output into a text file. And all I need to do to make this work, right, to make this become not just standard input output, but actually error output, is to add a 2 to the front here. Now when I hit enter and I do cat test.txt, you will see that the error message is now saved to this test file. Keep in mind, still the same rules apply. If I do double greater than sign, I will append to the file rather than overwrite. So let's run this again in cat test.txt. And as you can see, I have just appended the same error message twice. Right. So that is a brief introduction to input-output redirection. Right, we showed you the regular greater than symbol, the double greater than for append, and we also showed you how to not only do standard output or input-output redirection, but also how to do it for error input-output. So thank you for tuning in, and I will see you all in the next video. Hello and welcome. So for this video, we're actually going to go over the conceptual understanding of searching in Linux. Right, so I like doing these PowerPoints before denser lessons, right? I know the find and the grep command can cause a lot of people some issues, right, when it comes to learning it, right? So I just want to give us a conceptual understanding before we jump straight to the command line, right? So overview for what I'm going to talk about today, right? We're going to talk about using the find command, right? Key difference here between find and grep. The find command will search for files. The grep command will search for specific contents within those files, right? And we're going to drill that difference in as we go further through this lecture and then also through the next couple as well. We're also going to go over basic regex or regular expression, right? How do we search for things that we're not sure how those file names ends, for example, right? How do we search for things using generalities instead of a specific file name, right? Regex is going to help us with all of that. Then last but not least, we're going to use the grep command. As I said before, instead of searching for specific files, this command will be used to search for the content within files. Right? The best way to think of grep, in my opinion, is think of using Google Chrome, the Control F command, right? That is when you are searching on the page for a specific string or body of text, right? Very similar with grep. So the find command, right? The find command is going to be used to search for files, and it's going to use the following parameters, right, as its search type. Right? It's going to either look for name, permissions, size. It could look for the modification date of that file, the creation date, right, and many other parameters are possible there as well. And as we see at the bottom, the general usage for it, and we'll see this more in the command line, is the command name find, where we're looking. Are we looking in our current directory, the root directory? The search parameters, right? Are we looking for it via name, size, permissions? And lastly, the value, right? What is the actual name? What is the actual size we're looking for? Next up, we have wildcards, right? So these are used to specify generalities. And what do we mean by that, right? Let's say I know I'm looking for something that starts with PASS, right? Anything that starts with pass, right? It could be password, passwords, pass1, pass2, right? What I could do is I could put PASS and put a wildcard at the end, right? That wildcard, right, in this case the asterisk, can represent anywhere from 0 to infinity characters of any type. Right? I know that 0 kind of looks like an O on the slides. Unfortunately, that is the way the Georgia font represents it, right? But keep in mind that with that little asterisk that you see on the second bullet point, that will represent 0 to infinity characters on whichever side you put that asterisk. Additionally, right, we have the question mark wildcard. Let's say I know I'm looking for pass1, pass2, pass3, pass4, right? Files of those names. What I could do is I could put PASS question mark, right? And it will find all those files. The main thing to keep in mind with the question mark is it needs to be exactly one character. Right? If I do PASS question mark, right? A file named PASS, right, or just pass, would actually not pop up. And the reason for that, it needs exactly one character after PASS, right? And this will become more clear as we see it in practice, right, in the next couple videos. Last but not least, right, we can also specify characters from specific ranges, right, using these two brackets. I could either do A through Z, 0 through 9, right, or I could do A through 9, right, as well as a combination of those two. Now, the reason why this is important is, let's say instead of using the question mark and representing any character, right, I wanted to say, hey, I only want to look for files that end in a number, I could use these brackets instead. Right? Last up, grep command. Right? We talked about find, searching for specific files. Now let's talk about grep. Right? This is searching for the contents within files. Right? Once we type grep, there's going to be a pretty simple usage example here. Right? We use the command grep. We put the string we're looking for. Maybe it's like passwords, and then the text files we will search for that string in. Right? And we'll show this in practice later on. Keep in mind the reason I have files right in that parenthesis is because you could specify multiple files, you could specify a single file, or you could even specify entire directories that you want to search through as well. So that was searching in Linux in a nutshell, right? In the next couple videos, we're going to dive into the actual hands-on practical part of this section. So thank you for tuning in. I will see you all in the next video. Hello and welcome. So last time we talked about how we're going to go over the find and the grep command. For the purpose of this video, we're going to go over the find command and also use a little bit of regex. So let's jump right in. Right, when we learn a new command, one of the first things we could do is we could use the man page on it. So I'm going to type in man find, and this will give me the name, a synopsis, a brief description, and also talk me through some popular options here. Right, so pretty good page to read through when we're learning this tool. I'm going to quit out of that by clicking the Q command. And next up, what I'm going to do is I'm going to create some files that I want to find. Right, so I'm going to touch, let's do dog1.txt. Let's do dog2.txt. Let's do 2dog2, 1dog2. Right. Now, what I could do here, actually, let's just make it a general dog.txt. What I could do here with the find command, right, is I could type in find. Right, I'm going to specify the directory I want to look in. Right, for the purposes of our first find command, I'm going to use the dot here. Right, this specifies to look in just our current directory. Right, we're not starting and looking through our entire system. We're just looking in this specific documents directory. I'm going to specify how I'm looking for that thing, right? So we have find, where we're looking, how we're looking, right? I'm going to look for it via its name property. And then lastly, the value we're looking for, right? And I'm going to do dog.txt and hit enter, right? And you'll see it will pop up with the results there. Now the question is, what if you wanted to find all, right, all of the dog.txt's or any txt file that has just dog in it? Well, what we could do here is we could start using regular expressions, right? So let's say if I add at the end of our command here, find dot dash name dog, this wildcard and hit enter, right? You're going to see I actually need to put in parentheses, or excuse me, quotations for this to work. You're going to see that I'm going to get multiple results back, right? As we spoke about before, right, in our demo, right, or as we spoke about before in that PowerPoint that we talked you through. Hello and welcome back. So we're going to be using the find command and learning a little bit of regular expression in this video. Right, so as you see here, I have my documents folder, and I have a couple of files that I added, all these dog files, right, that we're going to be searching through and finding today. Right, so the first command I'm going to show you, or the first usage of find, is I'm going to find just this file, right, dog.txt. In order to do that, I'm going to use the find command, dot to represent this current directory, dash name to represent how I'm looking for that file, and then I'm going to put dog.txt, right, and I'll put this in quotations. So what we see here is we see first up is the command. Second up is where we are searching for this file, right? Keep in mind, I'm not searching through my entire system. I'm just searching this directory. So we have where we're searching, how we're searching. I'm searching via name specifically. And then last but not least, the value that we are searching for. So when I hit enter, right, you all see I return one value back. Let's get that command back and let's try using a wildcard. Let's say I wanted to see all of the files that started with dog but had some text after it. Right? What I could do here is instead of ending in .txt, I could use the wildcard at the end here. Right? And what this wildcard is going to do is it's going to say, hey, for every file that starts with dog, right, I am going to return it regardless of how it ends. Right? If we hit enter, we'll see that. Dog, dog1, dog2.txt, right? Let's just try to get every file now that has dog in it in general, right? Let's just try to get every single one. Right? I want you all to take a guess how we would do that. Where would I put the other wildcard? Thank you for tuning in. I will see you all in the next video. Hello and welcome back. In the last video, I asked you all to pause the video and to say what you think the output of this command is going to be. If you have not gotten a chance to do that, please pause the video now. It's going to be helpful for you all to learn when you make these educated guesses and you see the answers shortly after. So pause the video now and we will show the answer shortly. Well, if you guess to the left of dog, you'd be correct, right? If I do asterisk, right, that little wild card, dog asterisk, I'm going to say, hey, I don't care how many characters are to the left. It could be 0 to infinity, or how many characters are to the right of the dog string, right? It could also be 0 to infinity. I just want you to return everything with dog in it. We'll get all of those files. Now keep in mind, right, we can complicate things a little bit further. I'm going to make a couple more files for this. Let's do dog12.txt. Let's do dog 1, 2, 3, 4. Ooh, touch dog 1, 2, 3, 4. Right. What I could do, right, to make things a little bit complicated, right, is I have all of these different files. I'm going to pull up my previous command. Instead of using asterisks, I could actually use question marks. What the question mark will represent is exactly one character to either the left or the right of, depending on where I put it, right of dog in this case. Right, so if I put a question mark here, I want you all to guess what is going to be returned here. I have question mark, dog, asterisk. Remember, this question mark has to represent at least and at most one character, right? It is exactly one, right? So take a guess at what will be returned. All right, let's hit enter and find out. Right, as we see here, we returned one dog2.txt, two dog2, right? But notice what hasn't been returned. We didn't return dog.txt. And the reason for that is because there is no character to the left of this. Therefore, this question mark is not actually going to be fulfilled. Right? Now, another way to use the question mark, let's say, right, we have dog 1, 2, 3, 4. What I could do here is instead of using the asterisk, I could use 4 question marks, right? The first question mark is going to represent the 1. Second is going to represent the 2, 3, and 4, right? When I hit enter, right, you're going to notice I actually returned 2 files, which is pretty fascinating, right? This first one, right, because it starts with dog and has exactly 4 characters after it. And then also, right, we see dog.txt is returned as well, right? And the reason for that is because we have dog and then 4 characters after it as well, right? So keep in mind that question mark is also the case. Now let's say I'm going to create a couple more files. I'm going to do dog, dog.a.txt, dog b.txt, right? And I'm going to pull my command back up once again. What we could do now is instead of using question marks, we're going to use the third tool that we've used before, or the third tool that we went over in the PowerPoint slides, and that's going to be the brackets, right? I could actually do brackets and specify what characters I'm looking for the next, basically the next command, right? I'm going to do A through Z, right? And I'm going to do .txt, right? What this is going to do is it's going to say after dog, we want at least one character, right, to have A through Z, right? In that case, dog A and dog B would fit that bill. What wouldn't fit this bill, right, or what wouldn't match this regex would be dog 2, dog 12, dog 1, anything with a number in it after dog will not work, right? So let's hit enter. And as you see, as I had just spoken about before, right, we return dog A, dog B. I want you all to pause the video and change the A through Z into something that would get all of these text files with exactly one number after dog, right? How would we do that? All right, well, if you guessed by changing A through Z to 0 through 9, you are correct, right? We get dog 1 and dog 2.txt here, right? So that's the find command using names. However, as I said before, this isn't the only way for us to search for things. If I do ls-l, I can actually see, right, a couple of things that are interesting to me. The first is I could see the size of files, right? So I see 0 here. I can see the size of the directories, right? I know it's a directory because it's in this dark blue. I can also see permissions. Now, I'm not going to show you this video how to find files via permissions because we have a section later on in the course where we dive much deeper into permissions, file permissions, user permissions, and all that. But what I will show us is how to search for specific files based off their size. Right, so let me clear my screen and pull up my previous find command. So instead of searching for name, I'm going to do -size, right? And let me actually look at the sizes one more time to see what I want to look for. I'm going to search for only the files with a size of 0, right? So the files that have no contents in them. So I'm going to do, right, if we pull up our find command again, find dot, right, once again looking in just this directory, -size, and I'm going to do 0C, right? And if you're curious what C stands for, it stands for bytes, right? So this is the amount of bytes that would be held. If you put 0, the unit that you put after should not matter, right? We're going to see actually a lot of files pop up, right? So dog 1, dog 12, right? All of the files that are empty and not and have not been added or have not had any text added to them will all pop up, right? We also see there's some hidden files that pop up, right? And this is the power of the find command, right? So we could find files that when I ls do not pop up, right? We notice there's actually a period in front of some of these files, right? When a file starts with a period in front of it, it will actually hide it, right? It'll be a hidden file, right? And we can see that if I do ls, right? I don't see anything in here, right? If I cd into the hidden directory and do ls, I see these regular password files. But if I do ls space -a, right, for find all, you will see there's actually a subset of hidden files that start with a period that we do not see. Now, one thing you may have noticed, right, is that the find command didn't just search into the current directory we're in, it actually just started there, right? So let's cd back out. I'm going to clear and I'm going to rerun the find command again. Right, keep in mind, right, you could actually tell that these files here, right, all of the ones with the hidden directory, they're actually one directory deeper.
So by specifying the period here, we're actually just saying the starting point of the find command. It will actually dive into each directory, right? It will dive into this directory, this directory, this directory, search through them and see if any of their files match our bill. Now, let's say we wanted to check our entire file system for something. Let's say we're doing this in a security context, right? And we want to look for anything with, let's say, pass in its name, right? So it starts with PAS and has anywhere from 0 to infinity characters after that. What I could do is, instead of starting my search in this current directory by doing this single dot, I could do a / and specify that I want to start at the very beginning of my system, right? This is called the root directory. And you're going to find a lot of stuff's about to pop up, right? So we just found every file that starts with PAS, and it's still looking. And a lot of those files we actually do not have permission to jump into, right? But if we look, right, we just found every file, passwords, password.svg, password.png, right? Every file that starts with PASS we have just found on a system. Right now, this is obviously the benefit of it from a security perspective, but if you have no idea where a file is on a system, you just know that that files exist, this could come in, it can come in handy. Let me clear out. Keep in mind, when it comes to using wildcards, this isn't just something that's true of the find command, right? Wildcards actually can be used for other commands like rm, right? Like I'm going to rm anything that has dog in it. So I'm going to do star, dog, star, hit enter. And if I do ls, you will now see that all of the files that had dog in it are now gone. All right. So that was the find command. In the next video, we're going to jump into the grep command and also talk a little bit about piping, and we'll dive deeper there. But thank you for joining us, and I will see you all in the next video. Hello and welcome back. So in the last video, I gave you the task of trying to create and delete a file in our documents directory. If you've not had a chance to do that, please pause the video now and attempt that. Right, as a quick reminder, the two commands you're going to need to use are going to be touch and rm, right, to do the creation and deletion process there. So please pause the video, and once you get that done, we will segue into the next part of the video here. All right, so as I mentioned before, now we're going to go over the grep command. So we talked about find last video, now we're going to talk about grep. Right, remember the key difference between the two is while the find command will find specific files, the grep command will actually dive into those files and search for specific contents. Right, so let's see what that looks like. Right, so here is my current setup with files. If I cat my passwords.txt file, you're going to see that there are, it looks like 10,000 lines, right? And if I just was to scroll through this manually, it might be hard to find anything of value, right? You know, I know this is a passwords.txt file, so there's probably a password in here somewhere. So I'm going to clear this out. I'm going to use grep to do the searching for me, right? I'm going to use the grep command. I'm going to use quotations, and I'm going to say what I'm searching for. I'm going to look for the word password, and then I'm going to feed in the file name that I just opened up before it hit enter, right? And as you see, I actually just pulled out the password from that file, right? There were 10,000 lines that were just filled with nonsense, but somewhere in that file, I know this line is there. Now to double check this, what we can actually do is we can add an option to grep. I could do grep-n, and this will print out the file line number as well, right? So I see it is on line 127. So if I cat this file again, right, and I scroll up to, let's say, line 127, I'm not going to scroll wheel that. I'm going to use this. 127. Oop, I just passed it. Right, you'll see, hey, there's our password. Right. So you already can see the power of grep, right? When you just have loads of text that may not be interesting to you or just may be straight nonsense like this file, right? You can still grep for things that are important. Keep in mind, what we can also do with grep is we could use regex, right? So let's say I didn't know that it ended in password, but I did PASS asterisk, right? I will still find that file, right? So that is an interesting piece as well. Another thing to note is I don't have to specify a specific file, right? What I could also do is specify a location. Let's say I did // an asterisk, right? This is basically saying I want you to search this current directory through all of the files for the pass string here, right? Let's see what we get.
you're going to find that a couple of these will give errors, right, because you can't search a directory, right, via this. But what we will find is that there actually is one random file here with passwords as well, right? Or, well, technically no passwords, but with that PASS string, right? And we find that as well. So keep in mind at the end here, right? We don't have to just specify a specific file. We could also specify an entire directory, right? You could also use, if we wanted to recursively search, right? So let's say we wanted to search through these directories, directory, IoT, loop files. I could use grep-r, right, which stands for recursive. Now it didn't find anything in those other directories, but you see it's no longer giving me an error. So let me actually, I'm going to add in the hidden directory. Echo password is hello. I'm going to echo this into random file.txt just to demo this. And I'm going to cd out of this directory. Do Control L to clear screen. So let's use that same grep command. I now have in a deeper directory a file with a password string in it, right? And when we hit enter, you'll actually see that with the -r or the recursive option, we are also searching in all of these directories now, right? So we're not just searching for this current directory. We're now diving into scripts and loop files and hidden and IoT test, right, in order to do that, right? So pretty interesting stuff. So that is how we use grep. Keep in mind, right, the ./, you could also just do /*, right? And as you could see, if you could guess, right, this is searching through my root directory and is finding all of the files that have PASS in them, right, and any amount of characters afterwards, right? So this will obviously take quite a while, so I'm going to Control C out of that, right? So it's important to know what we're searching for, right? Remember, if I put the dot here, I'm going to start my search in my current directory instead of starting it from root and searching through my entire system. So that is the grep command. Thank you for joining us, and I will see you all in the next video. Hello and welcome back. This is going to be the final topic in section 1 of Linux fundamentals here, right? And we're actually going to show how to use what we call a pipe, right? How do we take the output from one command and pipe it or send it over to another command, right? And before we do that, there's just one tool that I want us all to install. It is going to be called the curl command, right? So just type in sudo for superuser-do, apt, right? This is our installation tool, the install keyword, and then the command we want to install, curl. For you all, it's going to prompt you to put in a password, and also it's going to have a couple more lines below because it's actually going to install it, whereas for my system, I already have curl, so I don't have to go through those steps. But once you install curl, I'm going to talk you through what it does. Right? The best way to think about curl is it's an HTTP client in our command line, right? And what do I mean by that? Right, in the same way that our URL browser here is an HTTP client, and if I type in example.com, right, I get this web page, we could do something very similar in the Linux command line. Keep in mind that instead of seeing a rendered web page in front of us, what we're actually going to see is the source code, right? So everything we see here, this is what's going to be pulled when we use the curl command, right? So let me demonstrate that. When I type in curl example.com and hit enter, right, we now see, and I'll make the screen a little bit smaller, all of the source code, right? And this is going to be identical to what we see here. Why is this interesting to us? Well, a couple reasons, right? If you're writing a web scraper, right, you might want to use curl to pull all of that page source code, right, and to scrape the web that way. However, the purpose of this lesson, right, the reason we're going to use curl is I want to show you how to pipe commands, right? And I'll tell you what I mean here. So when I do a curl example.com, right, we're going to see we get a ton of text, right? This is actually a relatively small website, but you could probably guess that for bigger websites, there's going to be much more text here. What we could do, right, is we could pipe this output, right, the output meaning all of this source code, into another command, right? I'm going to use the grep command to demo this. So I'm going to do shift key, and I'm going to hit the backslash, right? So shift backslash. It's going to make this straight line, right? This is what we call a pipe. And I'm going to do grep, and I'm going to grep for the string example and hit enter. Now what's happening, right, and I know there's some extra noise up here, but I'll show you how to get rid of that in just a second. What has just happened, right, is we curled for example.com, we got all of the page source code as our output, and then from that output, we grepped for the lines that have the word example in them, right? Now keep in mind, we get this extra noise up here, and if we want to get rid of that noise, we could do curl-s. This is silent mode for curl. So I'm going to hit enter there, right? You can see I just get the lines now with the text. All right, why is this helpful? Let's say you're looking through specific articles and you want to look for specific keywords, right? You're going to want to pipe the grep command here, right? So keep in mind that grep is not only a command that works on files, it can also work on the output that comes from other commands as well here. Right, so that was a quick little introduction to the pipe command. Of course, we're going to dive deeper into this as we continue to chain commands and make more and more complex command line queries here. So thank you for tuning in, and I'll see you all in the next video. Hello. So for this video, I'm going to talk you all through different exit status codes, right? Just a couple of the main ones is mostly what we're going to focus on, and talk about the real concept behind the exit status. So let me demo what I mean. If I do cat, or let's do ls, right? So I just ran a successful command. What I could do is I could do echo $? And it will give me a number back, right? This number, it's not just a random number, it's actually a status code for the previous command I just ran. So if you run something with 0 issues, you will get the 0 status code back. However, if I run something that has an issue, let's say I do cat, and let me cat a file that doesn't exist, non-existent, and then I do echo $? You're going to see I get this status code of 1, right? So where 0 represents that there are no issues, there are no errors that have popped up, 1 represents it's a general status code for errors. Right now, there are more specific errors that could pop up. Right? I believe 126 is for command not found, 127 is invalid arguments, right? There's a whole list of them. But the main thing that we should understand, right, is that the most popular difference is 0 and 1. 0 means successful, your command ran with no problems. 1 is a general catch-all for all issues. Now, why is this relevant? Well, let's look at a script I actually wrote for this. So let's look at the exit status script I wrote, right? And I'm going to walk us all through the purpose of the script and how this status check actually can help us out. So right here, right, we have cat file2.txt. What I did here, right, was I put 2 greater than dev null, right? The reason I put this is if this runs and throws an error, I don't want that error to output to my console, right? I don't want to fill up my console with unnecessary errors. Instead, I'm going to throw it into this dev null bin, right, which is basically like my garbage can for all the errors, right? So I'm just redirecting that output, which we have covered previously in a couple videos back. What I've done here, right, and we're going to learn more about scripting later on, right, so do not get too caught up in the weeds here, right, is I've made a conditional saying if the status code equals 0, right, meaning that it's successful, print the script has ran successfully. Else, if the status code does not equal 0, right, in this case it's going to equal 1 when it doesn't print successfully, print the script has failed and exit with that failure status code. Right? So all the script is doing, and I'll comment it, right, is this is conditional saying if status code is equal to 0, then we are printing this out. Else, right, so this would be if status code is not equal to 0. If status code is not equal to 0, then we will print this out instead. Right, so let's run this script, see what we get, and then we'll adjust it a bit. Right, so if I run exit status, it's going to say the script failed. And the reason for that is, right, I'm catting a file that doesn't exist. But let's try catting a file that does exist and see if our output changes. So let me change this to, I believe I have a file called passwords.txt. Passwords.txt. I'm going to escape WQ out of this now that I've changed it. Let me just make sure, yep, so this file exists and should work. Let me run it again. Right, so we see 2 things have actually happened. Right, first, it has catted the file, right? And then secondly, the script has ran successfully, right? So we see it actually has worked. Right, and we could see, let me change it to another script that exists. Let's do echo.txt. Right, you can see this will work. As long as the file exists, right, we will hit that first conditional. So I think it's echo test is what it was called. Let's run it one more time. Oh, actually, it's echo text, right? So I want you all to guess, since the name is wrong, what are we going to get? Is the script going to succeed or fail, right? So feel free to pause the video and to guess there. Well, if you guessed that it's going to fail, you are correct, right? Script has failed because this actually needs to be the right name.
Keep in mind I'm using Vim for this, right? But if you all want to type up the script as well, right, you can use Nano, right? Whichever you choose, totally fine. Vim is a little bit tougher for beginners, right? Because you, instead of doing Control X to quit out, you have to do Escape :WQ as we had showed previously in other videos. So I just fixed the text here. So now this should work. Let's run it. You can see it printed the contents and has said the script is ran successfully. So that is exit status codes in a nutshell, right? The main ones being 0 for success, 1 for errors, right? Or just general errors. And once again, the main reason why you would do this is if you automate a script, right? You want to understand, did your script run successfully or did it not run, right? So you want to keep track of those different status codes. So thank you for joining us for this video. I will see you all in the next one. All right, well, thank you for joining us for section 1. Just a quick overview and quick wrap up here. We got you all set up in the Linux command line system, got you all familiar with some of the most basic commands such as cd, ls, grep, find, right? Some of the quintessential commands that you need to be proficient here. What we'll be moving on to next, right, is we'll be talking about where data is stored, right? We'll talk about different processes and how to find them in the Linux system and much more. So stay tuned for section 2, and thank you all for joining us for the first section here.